Good evening, everybody. Welcome to Chem 170 with your host, me, Dr. White. I'd like to apologize. Uh, every once in a while, Zoom gets me, and it got me tonight, where I had to uh, do the Zoom office hour login, and I won't go into why, but Zoom does that once in a while, and it did today. All right, let's get to work. Let me remind you that this Thursday, I will be giving test number 3 online. And at Thursday, about 8 a.m. or earlier, I'll send out the password for test number 3 PDF file, which you can download from D2L. You'll have until 8 p.m. Friday to finish it. And test number 3 has 9 pages, 10 problems. Some of the problems have multiple parts. It will cover carboxylic acids, esters, carboxylate anions, amines, amine salts, quaternary ammonium salts, which are near and dear to my heart, amides, and heterocyclic compound. The breakdown, 7 points general knowledge, 38 points nomenclature, and 60 points reactions. There'll be five bonus points. And the reactions, I think I have 3 or 4, I can't remember which, synthesis problems where you have to give the starting material or materials for a reaction. But most of them are give the product or products for organic products for the reactions. All right, let's start the review. Remember, what you're seeing now is in the lecture section of D2L. I'm not sure if this part you have to click at the bottom more to see it, but anyways, it's there. All right, let's begin. First, what's a carboxylic acid? Carbonyl, carbon double bond oxygen with an OH and an R group. How do you name it? You find the longest chain with the carbonyl carbon, name it as an alkane, drop the E, add OIC in the word acid. The carbonyl carbon is always number 1, so you don't have to put that, and the rest of the substituents you number accordingly. Hopefully you've done the problem sets and watched the videos. All right, I'd like you to know 3 common names. First one is acetic acid. That's this carboxylic acid, where R in the carboxylic acid is a methyl group. Where do you find acetic acid? Well, vinegar. Vinegar is about 4% acetic acid and 96% water. And if you also look at your bottle of ketchup, well, I don't have one, or mustard, it has the vinegar in there, which means it has acetic acid. And so does if you buy a jar of pickles. The liquid in the pickle jar has vinegar in it, which has acetic acid. All right, when R is a hydrogen, that's formic acid, and that's mixed with water, heated up, the defensive weapon of the fire ants. And finally, when R is a benzene ring, both the IUPAC and the common name is benzoic acid. All right, they're called carboxylic acids because the hydrogen and the oxygen that's bonded to carbonyl is acidic. And if you react it with a base, MOH, hydroxide base, where M is lithium, sodium, or potassium, you get the carboxylate anion, the salt. Now, a special case is the base sodium bicarbonate. I think this is one of the 2 reactions I'll ask you all semester to give all the products. And sodium bicarbonate baking powder reacts with a carboxylic acid to give the carboxylate anion and carbonic acid, which immediately breaks down to water, and carbon dioxide, which is given off. That's what the arrow up means, as a gas. And hopefully you all saw the video where I talked about how my father taught me when I was about 5 years old, take that little rocket ship that had the awful candy in it, pull the tube off, put in some vinegar. That's when R is CH3, sodium bicarbonate, baking powder. Shake it up, put the cap back on real quick, and it builds up CO2, and the cap, boom, pops off, just like firing a rocket. Oh, that was so cool. My friends thought so too. All right, how do you make a carboxylic acid? If you start with a primary alcohol and oxidize it heavily, you will get a carboxylic acid. It won't stop at the aldehyde. And as I mentioned, this is the reason why wine that goes bad, ethanol, primary alcohol, there's oxygen in it. After a number of years, it'll turn some of the alcohol to vinegar. And bad wine tastes like there's vinegar in it. You have an aldehyde, you can also oxidize it to carboxylic acid. Finally, one that I like, and I've actually used in my PhD synthesis, you take a Grignard, react it with carbon dioxide, CO2. Remember, X is chlorine, bromine, or iodine. Second step, acid water. You get a carboxylic acid that's 1 carbon longer than the R group you started with. That's a neat reaction. Dr. White loves Grignard reagents and reactions. It's one of those special reactions where you make a carbon-carbon single bond. Now, later in the semester, we'll come back to carboxylic acids. We talk about fats and oils, and that's an area in the chemical industry where I've worked. You'll learn more about that later on. All right, now let's talk about derivatives of carboxylic acid. A derivative is something that's derived from or made from carboxylic acids. The only one I'll talk about, other than the carboxylate anion, is an ester. Ester has a carbonyl, carbon double bond to oxygen with an R group, oxygen to the carbonyl carbon, and on this oxygen is a different R group, R prime. Now, how do you name esters? Well, you name the R prime in the front as the alkyl group it is. Next, there are 2 methods. Years ago, I had a really sharp, I'll go through in a second. The IUPAC way is name the carboxylic acid used to make that ester. If R prime were H, what was that carboxylic acid? Drop the IC in the word acid and add AOATE. And you still have the R prime in front. Now, I had a really sharp student a long time ago in Chem 170. He said, you know, for almost everyone except benzoate esters made from benzoic acid, you can do the following. And he was right. If we have this ester, name the alkane as the R group of the carbonyl carbon. Drop the E and add OATE. You still have the R prime in front. And let's do an example. And here, what functional group do we have? We have an ester. Carbonyl, oxygen on the carbonyl, R group. On this oxygen, we have another R group I'll call R prime. This is an ester. And I'll use the student's way. 1, 2, 3, 4. That's butane. Drop the E, add OATE, butanoate. And here our prime is an N-propyl. And that would be N-propyl butanoate. Now, where you can't use the student's method and you have to use the IUPAC method is this ester. And notice we have a benzene ring to the carbonyl carbon. So the R prime is methyl, that goes on the front. The carboxylic acid this would come from would be benzoic acid. Drop the IC from benzoic and the word acid, add ATE, and it's now methyl benzoate. And when you have an OATE ending, it can either be either an ester, or I'm going to go through right now, a carboxylate anion. And an ester starts, the name starts with an alkyl group. A carboxylate anion starts with a metal or an anion, an element. An element's name like sodium, lithium, or potassium. But let's continue. Now, there's only one common ester I asked you to learn. Nobody ever calls this ethyl ethanoate. It's called ethyl acetate. And remember, that's the key ingredient, the main ingredient in one type of nail polish remover. For many, many years, that was the main nail polish remover. And a couple of years ago, when they came out with the super hard, notice I'm wearing some, no, I'm not. But anyways, nail polish that you cure or harden under UV light, ethyl acetate didn't work as well as acetone. So now if you go into a place like Target or Walmart, you'll find most of nail polish remover is acetone. But years ago, it used to be the opposite, ethyl acetate. Now, how do you name a carboxylate anion? And I'm going to keep it simple where the anion M is from lithium, sodium, or potassium. Now, here, when you have a carboxylate anion, you name M plus as the element it comes from. And for my class, that will either be Li lithium, Na sodium, K potassium. And then the rest of it is just like an ester. Name the either 2A, name the carboxylic acid used to make that ester, drop the IC in the word acid and add OATE, or if it's not, where R is not a benzene ring, you can use that student's idea, name the alkane it comes from, drop the E and add OATE. Now, when we talk about esters, and now we're getting to that time of the year, spring, or if you go out and take a walk, you can go and smell the flowers soon. And you should know esters are responsible for the smell of most flowers and the taste and smell of many fruits and vegetables. Even though I hate them, when you smell a banana, you're smelling an ester. And in a couple of weeks, when the flowers start coming out in spring, and I'll be walking around my neighborhood, now inhale and smell the flowers in the air. I'll probably be the only one in my neighborhood thinking, I'm smelling esters. Now, you know he's an organic chemist, and I am. All right, how do you make an ester? You take a carboxylic acid and react it with an alcohol in the presence of acid, and you get an ester. The carbon with OH and R prime is the carbon the oxygen is bound to an R prime in the ester. The carbon in R prime with the OH is the carbon O oxygen is bonded to an R prime. By the way, I forgot to mention, this is called the Fischer esterification reaction, named after the great German chemist Emil Fischer. And we'll learn more about him. He's more known for, this alone is a lifetime achievement when we did it, but he's more known for his work with sugars. We'll talk about later on. All right, now, once you get an ester, if you take acid and water, H plus is acid, you'll do acid hydrolysis in ester, and you'll get back the carboxylic acid and the alcohol you would have used to make that ester. And we'll learn later on in the semester, this is a really important reaction. We said about all the reactions, but this one is going on in your stomach. And we'll learn later in the semester, whenever you eat anything with a fat or oil, which are essentially esters, and the acid H plus from hydrochloric acid in your stomach, I still think that's one of the great miracles of life, that you and I both have cells in our stomach that make hydrochloric acid. Amazing. But anyways, that acid and water breaks down the fats and oils, we'll learn later on in the semester, to alcohol and carboxylic acids. All right, now, this is acid hydrolysis in ester. This is base hydrolysis. And the base I'll use for this class is either LiOH, NaOH, KOH. M is lithium, sodium, or potassium. In the presence of water, you get not the carboxylic acid, because as soon as you get that, that reacts with the base to form the carboxylate anion. So you don't get the carboxylic acid you would have used to make that ester and base, you get the carboxylate anion. If you put the carboxylic acid there, I'll take all points because it's wrong, and it is. And you also get back the alcohol you would have used to make that ester. Now, Dr. White's smiling because this is a great reaction. And that is, take an ester and react it with not 1, but 2 moles or molecules of a Grignard. And actually, I don't have here, but it should be chlorine, bromine, or iodine. Second step, acid and water. You get 2 alcohols. And the first one, you made not 1, but 2 carbon-carbon single bonds. And this OR from the alcohol, from the ester, is kicked out to give the second alcohol. Let's take a look at this. Let's have some fun with it. And let's look at this reaction. And what do we have here? Remember, always, when you look at a molecule, look for what's different. What's not carbon, what's not hydrogen, what's not a carbon-carbon single bond. to get your attention like that. And here, what do we have? Two oxygens. And we have an R group, carbonyl, carbon double bond oxygen. Another oxygen is the same carbonyl carbon. And on that carbon, we have a methyl group, R prime. Now here, we've got two. And that's a Grignard. Remember, X can be chlorine, bromine, or in our case, iodine. Second step, acid, water. Keep your eye on the carbonyl carbon because that's where the fun is. Do you break carbon-carbon single bonds? No. Oxygen, yes. Carbon, no. So this R group is still this carbon. And then from the Grignard, remember there are two of them here, you form not one, but two carbon-carbon single bonds. And this becomes an alcohol. And this group right here becomes the second alcohol. So here's our prime. And here's our triple prime. All right, so the first alcohol will have R attached to the carbon here. That was the carbonyl carbon. That will be an alcohol. And now we're going to have the R triple prime, and this carbon that has the Grignard will be bonded to this carbon here. So the N carbon at 3, not once, but twice. Remember, there are 4 bonds to carbon. I gotta get this finger fixed one of these years. And then the second alcohol, our prime, is also a methyl group. And notice right here, in one step, we took a simple ester and a simple Grignard, and we made a very, very complex alcohol. That's a good thing. All right, that's esters. Let's move on to something near and dear to my heart. For many years, paid my salary that allowed me to buy new cars, pay my mortgage, do a whole lot of other things, and got me around the world. That's amines and amine derivatives. What's an amine? Now we're talking about nitrogen. And amines can be a nitrogen with an R group on it. Now, unlike carbon, nitrogen can have either 3 bonds or 4 bonds. And an amines that has 3 bonds to nitrogen. So the remainder are hydrogens. 1 R group, 3 minus 1, 2 hydrogens. So primary amine, I'm not going to ask you that on a test, but I'll use the terminology. 2 R groups, secondary amine, 3 R groups, tertiary amine. And here, most people don't use IUPAC. And I've worked in this industry, I have patents in this area. And so I only asked you to learn the common names for amines. Name each R group as the alkyl group it is in the front, and then add the word amine at the end. Now, there's a special name I wish you should know. This is both the common and the IUPAC name. That's when R is a benzene ring and you have NH2, and that's called aniline. And that's the ancient name that IUPAC said, you know, something, we're going to keep it. Now, aniline is an important compound in our daily life. You just don't know about it. It's used to make all the dyes, like for my cloth, my top and other things. It's made into that. Or it's made into other compounds that's used to make things like the seat cushion you're sitting on in your car. Hopefully you're not watching me while you're driving now. All right, now, when you have 4 groups on a nitrogen, 4 alkyl groups, they can be the same or different, and it's got a plus charge. Therefore, all molecules have a net zero charge. So you need an anion. For this class, I'll stick with the halogen anions, X-chlorine bromine iodine. This is a quaternary ammonium salt. And Dr. White has, I think, 4 or 5 US patents on quaternary ammonium salts that I invented. So they're near and dear to my heart. How do you name them? The common way, name each R group on the nitrogen as the alk group it is. And then add the words at the end, ammonium halide. Now, if it's X is Br minus, that's ammonium bromide. For chlorine, it's ammonium chloride. Iodine, it's ammonium iodide. Now, quaternary ammonium salts, I mentioned in my lecture, 2 main uses. One, fabric softener. Hope you saw the stories about that in my videos. And the other is an antimicrobial compound, like in the mouthwash I use. I hope you saw that story in my video. Now, you can have what's known as an amine salt, and this is a mistake here. No, it's correct. Oops, not correct. And amine salts have 1, 2, or 3 R groups. You can have, and it has to have at least 1 hydrogen, and then it has a counter ion. And you name it the identical way as the common name for quaternary ammonium salt. Now, how do you know whether it's a quaternary ammonium salt or amine salt? Well, if you don't have 4 R groups on there, it's an amine salt. Now, how do you make amines? If you take a primary amine and react it with ammonia, NH3, in the presence of base, you'll make a primary amine. The nitrogen goes on the carbon that had the halogen, and the base neutralizes the HX that's given off. If you take a primary amine and react it with an alkyl halide, you'll now get a secondary amine. And these are all nucleophilic attacks where the nitrogen attacks the carbon, kicks out what has the halogen. Same thing here. And you get a secondary amine. If you take a secondary amine and react it with the alkyl halide, you'll get a tertiary amine. I'll never ask on a test what's a primary, secondary, tertiary, but we're talking about the R groups. And finally, next one, and if you followed the video, when I started the chemical industry a long time ago, this was the first reaction I did research on to try and make hydrogenation of nitriles. A nitrile is a carbon nitrogen triple bond. And as with all carbon nitrogen, like carbon-carbon, 2 pi bonds, 1 sigma bond, and pi bonds you can break like that. So if you add excess hydrogen with a catalyst can be nickel, platinum, or palladium, you break the 2 pi bonds, and each atom of the triple bond gets a hydrogen, 2 hydrogens, and you make a primary amine. And I did research on this at a company that used this reaction to make a couple million pounds of primary amine a week. Yep, that much. Now, something very near and dear to my heart. And that is if you take a tertiary amine, react it with an alkyl halide, you'll form a quaternary ammonium salt. and X can be chlorine, bromine, or iodine. Remember, quaternary ammonium salts, one of the main uses is fabric softener. The other is the antimicrobial compound, like if you look at and pick up the bottle of Scope or the Walmart equivalent of it. And that has a quaternary ammonium salt, pyridinium ammonium, acetyl ammonium, pyridinium acetyl chloride. And that's a different way of common names. Now, before I move, let me just talk about something that is a little different with amines. This is dimethylamine. I can write it this way, but remember, organic chemists are lazy. And an easier way, when you have two or more of the same group on the nitrogen, you can put them in parentheses, and this tells you how many there are, 2, and this is the same thing. An example would be this molecule. And this is the way I probably write it on a test, but as an answer, you could also write, if you had to write it down as the answer, diethyl, 2 ethyl groups, and 1 methyl. And again, these are the same. And that's something we don't do on mainly in organic chemistry and carbon compounds, but do always in nitrogen compounds. Now, amine salts are bases. Remember, a base is a proton acceptor. And if you have an amine reacted with an acid where X can be chlorine, bromine, or iodine, like hydrochloric acid, like in your stomach, you'll form the amine salt. And this can be true for a primary, secondary, tertiary amine, which is why I have R and R prime can be hydrogen. And that's how you make an amine salt. Now, next, a derivative of amine, something that can be made from an amine, is an amide. And we'll learn later on, amides are very important in our life. All proteins are amides or polyamides. Your skin, my skin, what's here I have left, they're all made up of polyamides. And here we have the amides here. An amide is a carbonyl with an R group, and to the carbonyl carbon is a nitrogen. Now, on the nitrogen are R prime and R double prime, but note, R prime and R double prime can be hydrogen, or one or more can be alkyl. Now, how do you make an amide? You react a carboxylic acid with an amine or ammonia. Here, R prime and R double prime can be H or can be alkyls, and you get this amide. Now, in an amide like an amines, nitrogen has 3 bonds to it. Only in a quaternary ammonium salt and an amine salt do you have 4 bonds. Let's back up. Amine salt, hydrogen plus 3 R groups, 4 bonds. Quaternary ammonium salt, 1, 2, 3, 4 R groups, 4 bonds to nitrogen. But for amines and amides, you only have 3. So how do we make an amide? A carboxylic acid plus an amine or ammonia will form this amide. And let me give you an example. And I worked for a company, Axo, where we used a lot of ammonia to make amides, which we sold. Not this one, but other ones. What's the reaction? What's different here? Ooh, oxygen with OH. This is a carboxylic acid. Now here we have ammonia, but I can write it this way. And notice right here in this amine, R and R prime, double prime, can be hydrogen, which in that case is ammonia. And what do we get? An amide. Now here I have R, and here R prime and R double prime are hydrogen. So I have my carbonyl carbon, keep an eye on that. That's where the fun is. It stays a carbonyl carbon. My R group, which in this case is an isopropyl group. Just think how far you've come. 6 months ago, did you know what I was saying when I said isopropyl? Hopefully you do now. I know you do. And nitrogen, and you have two R prime and R double prime, R hydrogen. So I can write it this way, or I can have each hydrogen coming off separately off the nitrogen. Now, when you have an amide, if you react it, and I'm going to stick with only one acid for this class, HCl, an acid and water, you have acid hydrolysis of an amide, and you break the amide back to the carboxylic acid you would have used to make that amide. But the amine you have is a base, and it will react immediately with the hydrochloric acid to form this amine salt. Remember, amine salts have a net zero charge. So in this case, the anion will always be chlorine from the HCl, chloride. Now, remember, R prime and R double prime can be hydrogen or alkyl groups. Now, if you have an amide and react it with base and water, you'll break down base hydrolysis of an amide. You won't get the carboxylic acid like up here, because the base will react with the carboxylic acid to give you this carboxylate anion. But you will get the amine that you would have used to make that amide. Now, in this acid hydrolysis, we'll come back to that later in the semester, because that's how your stomach, remember your stomach has HCl and water, breaks down proteins, which are amides, to amino acids. And I'll be teaching that. That's when we get into really good, fun stuff. Now, finally, I talked about heterocyclic compounds. And you should know, what is a heterocyclic compound. That's a compound, a ring with carbon and other atoms, such as oxygen and nitrogen. A heterocyclic compound, which makes up a good part of the organic compounds in our life, has a ring of carbon and other atoms, such as oxygen and nitrogen. I asked you to learn the name of only one heterocyclic compound. That's pyridine. It looks like benzene, except one of the carbons in the six-membered ring is a nitrogen, not a carbon. By the way, pyridine, well, stinks, but it's an important chemical. And that's it for our review today. Does anybody have any questions?
Nope, no questions. Thank you.
You're welcome. Well, in that case, I'll be posting this as a video, and I'm done for today. Anybody
Thank you.
Thank you, Dorcas. Anybody wants to stick around after I'm through, ask any kind of questions, I'll be here. And with that, I'll say, remember, it means go in health in Yiddish, gehen gesund, which means go in health in Yiddish. And I'll also say goodbye.
Bye.
From Granny into Beverly.
Bye.
Bye now.
Okay, bye-bye.